Hey guys, Darren back again. Today I want to run through a topic on voltage, step down transformers, and getting the best out of your retro console in a foreign country. So you might have a Super Famicom, for example, you've picked up from Japan, but it runs off 100 volts from AC from Japan. How do you run that in Australia? Good question, right? So today I'm just going to cover the basics on power and what we can do to get around that sort of problem and get your console up and running. So first things first is here in Australia, we run this type of power connector. It is an AC general output socket, and it outputs around about 240 volts AC. So that's what we're dealing with. And our consoles and our transformers from foreign countries typically will need 100 volts. If you look here, this is a Japanese Sega transformer, 100 volts AC input. This is a Neo Geo one from Japan, 100 volts AC. So how do we solve this mismatch problem? Well, we can do it two ways. So we can use a step-down transformer, which I'll show you in a second, which takes the 240 down to 100. Or we can simply use a different power supply, which is designed to run at 240, but then output the correct DC voltage. So let's just go through it. So why is it AC and why is it DC? I'll give you a quick explanation of between those two terms, just so you understand a bit more of the background and why things are the way they are. So without boring you too much with the technicalities, back in the day, many years ago, there were two guys, Thomas Edison, who I'm sure have heard about, and Nikolai Tesla. I think his name is Nikolai or Nicholas. So you got Edison and Tesla. They used to work together for a while, and then competed on a topic between themselves, and that topic was AC versus DC. So the problem you've got a power station in your country, which is a coal or wind or some sort of nuclear or some sort of energy producing power station. It produces extremely high voltage and it outputs it to the power lines. To transmit that high voltage power down the power lines, which are just basically copper wires, over long distances, like multiple kilometers of distance, that has resistance in the wire, and it gets hot, and then the voltage will drop over the distance. So Edison wanted to push DC, which is direct current, which you maintain a positive side and a negative side, and you just push it down the wire. I won't get into the technicalities of what that means, but think of voltage as the size of a water pipe, the potential energy that pipe would carry. So you could put a lot of water down it, but not always. Sometimes you can just trickle water through it. And think of current as the amount of water flowing through, just like a river, a current of water. So voltage is the potential to do work. Current is the amount of electrons flowing through that pipe. So Edison wanted to use DC. And the problem with DC over a long distance is the resistance in the wires tends to pull down the voltage, and you just can't transmit it very far. So ultimately that failed. And AC, alternating current, where the polarity switches, so 240 volts at 50 times a second will alternate its positive and negative poles. You pump that down the wire and it doesn't get as hot, doesn't drop as much power over distance. So AC was invented by Tesla to push power long distances, and that's what we've got. That's why we have it coming into our house. So Tesla won the argument, and that's why throughout the entire world you've got AC voltage coming out of the wall. It's because it travels further over distance. That's all you need to know. Then we have these big bulky blocks of copper in the 80s and 90s. That's why they're so heavy to do transformation. And modern power supplies are switch mode. They use pulsing and very clever ways of switching power on and off very rapidly internally to regulate power. Very different topic, won't get into that. But AC was alternating for long distances. DC is direct for short distances and very controlled and small sensitive pieces of electronics. So every piece of electronics you have around the house, this the camera I'm recording on, your consoles, your computers, they all run on DC. Everything runs on DC, and it's only the transmission that's is at AC. So that's the background. I hope you weren't too bored with that. If you want to know, if you want to learn more, it's on Wikipedia. Just jump on, have a read about it, read about the history of the two guys. There's also some YouTube videos on that people have made, which are really quite interesting. So AC versus DC, what it does, and the history. Now on to the stuff that we're interested in, the retro stuff, running your foreign console in your country. First of all, 240 volts coming out of the wall. You know, if you're watching this in the UK, you'll also have 240, or in Europe, you'll also have around about 240. If you're watching this from the US, you'll have about 120 volts AC coming out of the wall. So your solution will be the same, but just a little bit different to what I'm going to demonstrate today. So let's measure the power coming out of the wall to begin with. This is a little bit dangerous, so I'd only recommend doing this if you know what you're doing, and you just take extra care with your probes here. So on our multimeter, first thing we do is we switch it to AC voltage, which is over here with the voltage with a squiggly line, not DC. It'll say AC up on the screen if you're lucky. And you select a range that's appropriate. So 40 is too low, 400 is the next range for me. I'm expecting 200 and probably 30 today. And you just go ahead and put the probes in the sockets. Now just be really careful doing this, guys, but yeah, just take your time. Probes in, look at the screen. It'll go up a little bit slowly, and there you go. We're actually running a bit higher right now. This number will fluctuate throughout the day depending on the load on the lines and things. So, you know, you might measure it and it might be different at that particular point in time. It's running a little bit higher today to 41.5. So that's what we've got coming out of the wall. So our first problem is, you know, a Japanese supply wants 100 volts. If we attempted to put these pins into that socket, it would blow that power supply and be quite dangerous. It could blow up in your face. So never do that. Luckily here in Australia, our pins don't fit, so they physically don't fit. They're different. But in America, you will have a socket that actually looks like the Japanese one, just the straight sort of vertical pins. You could put that in, and your 120 volts coming into a 100 volt supply transformer might work. It would just get a little bit hot, I think. So I would still be careful if I was you guys in the US. So the solution is to use, well, this is one solution, and I don't like this solution, but we'll get through that in a second, is to use a step down. This is just full of copper windings. It's very heavy. And all it does is it gives you a localized plug on one end that you can literally plug into your wall socket, and it'll take that high voltage and it'll step that down to an appropriate power level for your choice. You know, sort of 100 volt sort of range. Now, if you look here, this one is a 240 to 115 volt step down transformer. 115 volts is going to be absolutely fine for a 100 volt transformer from Japan, and probably also the US, no problem at all. So let's, you know, we're still on AC voltage on our multimeter, and we've simply plugged that into the wall. Let's have a look. It counts up, and there you go. It's outputting about 123. So, you know, close to what it says on the box, but not quite. What happens when you measure voltage and power is they typically need to be loaded to get an accurate reading, and that means running a console or running a load with some resistance across it. So even if you measure AC or DC voltage, you really got to be mindful of, does it have load across it? So that's a bit of a topic for another day, but close enough is good enough when you're measuring and just getting an idea of what the outputs are. Okay, so moving on. Let's say we want to run our Famicom off here in Australia. Well, we can use a step down. Let's just use, I know for a fact that this one requires an HVC 002, which is basically a 9 or a 10 volt DC output. And the current draw will just be what the console wants to pull. But you always want to supply, you know, at least an amp. I would always have your power supplies rated to around about 1 amp. But more is better on a power supply, the actual current rating, and the console will only pull what it requires. So one step at a time. this is a Japanese Nintendo Super Famicom requiring 9 to 10 volts. I'm going to demonstrate running it off a Japanese Sega transformer, outputting 9 volts and 1.2 amps of current. So this will be fine. We plug this into our step-down transformer, so we're feeding it proper AC voltage. Our output plug for a lot of the old Segas and the Famicoms is exactly the same. It's a 5.5mm DC jack. Plug it in, switch it on, we've got power, and if you look at my screen, it runs fine, as expected. So that's one way you can do it, and a lot of you guys are probably doing it that way, using step downs. Personally, I don't like it because you've got this big bulky step down transformer which is extremely inefficient. It's basically taking high voltage, passing it through one side of copper windings, produces a magnetic flux or bloom of magnetism, gets picked up in another separated winding of coil of copper, which has less windings, approximately half. So 240 down to, let's say, 120, that's half. So half the amount of windings on one side, and the electromagnetic bloom just goes across and induces a voltage on that half of the coil, and that's what we tap out. Very rudimentary way of doing things. They get hot, they hum, they burn power. Not my recommended way of doing it, but it does work. So that's one way. The other way is to use a local power supply that's been designed specifically for your country. And these are my personal Global Garage branded power supplies. As you can see, we have Australian pins. We have insulated Australian pins so that when they're in a socket, kids can't put, can't slide a piece of metal or a nail file underneath the pin and electrocute themselves. So in Australia, we have this insulation to protect kids from doing dangerous things like that. Once it's in and it makes contact, it's basically blocked off. So that's a safety feature. Never buy a power supply in Australia that doesn't have that. It's very dangerous, especially with kids around. And then you'll see 100 or 240. So mine will actually accept a complete range. I'll give you a bit of a zoom there. So mine can actually accept 100 to 240 volts input of AC voltage at 50 or 60 hertz. So I could actually plug this into here or the step down if I wanted to, and it would power the switch mode power supply fine. What's important is the output. 10 volts DC and up to 2 amps of current. That's perfectly suited for the Super Famicom. So let's give it a go. I'll zoom you back out. So this one that I sell will suit the Super Famicom, all the old Famicom range, Master System, Genesis, Mega Drive. It does the lot. So let's plug it in. We're taking 240 volts AC straight into the switch mode power supply. We're stepping that down and regulating it down to 10 volts DC. Coming out the end here at 10 volts DC. Do a quick check on that while we're here. Switch over to DC, put it on an appropriate range, center negative, and there you go, we've got 10 volts. So fairly confident this is going to work. Let's plug it in. Super Famicom, Japanese one running off an Australian power supply. We've got an LED, and we've got our ROM card firing up. So you see how easy it is? If you just get the right power supply for your country, you can run all your imported foreign consoles off local power. You don't need these big, stupid step-down transformers, which are just a rookie way of doing it. So you see what I mean? Global Garage, we make it easy for you guys. So check out the range, and I'll go quickly through the range now, and then you can make your choice on what you'd like. So to run through quickly the range that I sell, I'll just show you a few of them. Typical the Sega stuff, it's 9 or 10 volts. Now, that's a question that a few people are going to have. If it says 9, can I run 10? If it says 10, can I run 9? Yes, the answer is yes. You can. 9 and 10 volts it doesn't make a difference. I'll explain that in a minute, but basically it's fine. So I make a direct replacement for all the Sega and Famicom sort of stuff, and I set mine at 10 volts, and this particular one can supply 2 amps. So as we went through before, and that will basically power many consoles, and you can check out my range that suit that particular power supply. Other ones that I sell are things like this one here for the Mega Drive 2. So we know the Mega Drive 2 has a smaller yellow tip, and it's actually 4.75 millimeters. It's not 5.5 like regular consoles. And if you look down here, I think you can see that the input is still 100 to 240, so it's multi-input. This particular one is also 10 volts output and 1.2 amps of current. So the old Mega Drive 2, which I've got right here next to me, doesn't consume much current. Its requirement was DC 10 volts and 0.85 of an amp. That's 850 milliamps. So looking back at my supply, I hope you're going to focus on that. 10 volts, and I do 1.2 amps. So I give it more current capacity than what it's required. So current is one of those things that it's just water through the pipe. If you turn the tap on and pull water out, you're only going to consume what you want. That's how current works. So the current number on the supply just needs to be larger than what your console requires. That's all you need to know. Don't be fooled into thinking they need to match. The current numbers don't need to match. This just needs to be larger. Voltage needs to match pretty closely. 9 or 10 volts for most consoles will be absolutely fine. So that's the Mega Drive 2. That one is available, and we sell that one like hotcakes. That's a very popular model. The 10 volt one I showed you before, that one's the most popular because it does so many consoles. Another one that's a little bit different is Neo Geo. So some of the early Neo Geo consoles, if you look closely, actually outputted DC 5 volts and required up to 3 amps of current, which is quite huge. So low voltage, high current Japanese supply. So I did come up with a solution for that one, and it's one of my other models over here. So this one is standard input as usual, and if you look closely, 5 volts DC and 3 amps, so it's exactly the same as the original spec. It's modern switch mode, nice and light, nice and efficient, meets all the Australian certifications. Always look for the N136, that's Australia, and your country will have different certifications. This one's it's also a 5.5 millimeter DC jack, but yeah, we're running at 5 volts. So if I show you the console, here's a Neo Geo AES, very early revision I've got here. I'll just flip it over for you. If you look at the label on the back, it's a low serial, and the early revisions of these things used a different power supply. So pro-pow 2 versus like pro-pow 3 or E are the common ones. And the difference is pro-pow 2 and a few of the others is 5 volts. And some of the later ones, the pro-pow 3s and the other ones, are 10 volts. So you really have to pick your Neo Geo power supply carefully. Look at that label that I just showed you on the underneath of your console, and that pro-pow code, you can look it up on my eBay store, and I can then you'll reference the correct one to buy. I've done the research and worked them all out. So I can probably demonstrate this running if you like. I'll just do a quick shuffle of things, plug it in, plug some power in. So we're taking 240 AC out. We're going through my switch mode power supply, regulating down to 5 volts. For a Japanese console, we don't have to use the Japanese power supply. I'm going to need to give it AV cable. Just give me a second. Okay, so I'm going to plug in the AV. I'm just going to use composite video. Nothing too fancy for today. I'm just going to let me just reach forward and plug this in. Okay, just plug that in. I'll just put in a game. These consoles won't operate without a game, so you've got to put one in. Flick it on. And there you go. Running off my 5-volt power supply. There you go, Japan only. So this is a Japanese console, Japanese game. Off we go. Such a cool console.
Summer 1975. A nightmare.
Alright, well I won't get into this one. I'll just switch him off. That's not relevant for today. But cool game, that one as well. So pull that back out. And I'll demonstrate another one quickly for you. So that was a Japanese Neo Geo early revision, low serial number, running off a 5-volt supply. Just be careful with yours. Some are 5, some are 10, so get the right adapter. So let's pull that one apart. I'll keep this AV cable here because we'll use that for another console. I've got an American US Genesis here, so it's filthy. Apologise for not giving you a clean one to look at. I haven't cleaned this at all. I've actually picked up a whole box of these recently from the US, all faulty, all need some work. You know, that's what we like to do, right? We like to fix these consoles, so that's videos for another day, but I just want to demonstrate running another console. Yeah, you can use the same AV cable for the Genesis as the Neo Geo. Same DIN connector, same pinouts, which is cool. So it is for composite video anyway. So plug that in. Okay, so let's go back to our original 10-volt power supply, which I showed you earlier. That's the one that outputs 10 volts and up to 2 amps of current. So that's going to be spot on for the US Genesis as well. So I'm not sure if it says it underneath. I think what it'll give you, yeah, it does actually. Sorry, it does tell us. So always look underneath your console and just, you know, you can get an idea. Sometimes it'll list the model number of the power supply, so 1601, but if you're lucky it'll just tell you the raw specs. 9 volts at 1.2 amps. So let's get this running. We don't need a stupid 120 volt step down or anything ridiculous like that. You know, we can just use the proper power supply, 240 volts, regulating down to 10 volts DC. We'll put a game in and we'll fire him up. It's a bit old and dirty, this one, but it is what it is. We didn't actually get a power LED. I've got to fix that, but it's still running. It's running a treat. So running at 60 hertz as well, you can hear that. So yeah, it's a bit faulty. It doesn't it's just a complete mess. Ugh, even that switch is hard to move. So this thing's a complete mess. It needs a complete overhaul, but for demonstration purposes, that's enough. Running off localized power, Aussie. So you don't need to be seeking out 120 volt power supplies and using step downs. And guys, you know, just use your brain a little bit. This stuff's not rocket science. It's not rocket science. It's just simple power, guys. So, you know, just think about it. Think what you've got coming in. Think about where you want to head to, you know, DC 10 volts, and work out how you can do that conversion. My solution is to use the power supplies that I've designed for retro consoles. They're extremely modern, efficient, quiet, low power, low heat supplies that don't hum, don't produce interference, don't damage or ruin your retro consoles in any way. They're actually better than the originals because they're 25 years newer, modern technology, and they just work, guys. I wouldn't be telling you about this if I didn't support my own products. They are really reliable. I've sold thousands of them now in Australia, and I think out of the thousands I've ever sold, I only had 1 or 2 defects, and I just sent out a replacement in the mail and the guy was happy again. So never caused any problems, and I can't recommend them higher. So get onto that, guys. I'd recommend you to pick them up, and I'll always support you. If you buy from me, I'll always support you. I'm a trusted power seller. So that's it from me on this topic. You know, I hope you've learned a little bit, AC versus DC, and what you can do with the DC at the other end. And I hope you can get your foreign consoles running in your country. And we'll leave it there today, guys. All right, thanks again for watching.